Hi guys, and welcome back to Maths with Cats. So today we're going to be going over part 2 of parametric equations for AQA A-Level Maths. I strongly recommend, if you haven't watched part 1, to go back and watch part 1 now. I'll have it linked or in an iCard at the top somewhere. So let's get on with part 2 now. Find the Cartesian equations from the parametric equations. To do this, you need to rearrange to make the parameter the subject of one of the equations. This is normally t or theta. If the parametric equations contain trig functions, you need to use trig functions, which are covered in later in the course, to help rearrange. So the trig functions you actually need for what we're going to cover today are here. Like I say, they'll be covered in a later video and later in the course, but they're useful to know for now for this video. Sine of 2a is the same as 2 sine a cos a. Cos of 2a is the same as cos squared a minus sine squared a, which is the same as 2 cos squared a minus 1, which is the same as 1 minus 2 sine squared a. And tan of 2a is the same as 2 tan a over 1 minus tan squared a. I'm not going to go into too much detail about why they work for now, because like I say, they'll be covered in a later video. It's just something that you need to kind of know to be able to do this video. Give the Cartesian equations in the form y equals f of x of the curves represented by the following pairs of parametric equations. A, x equals t plus 1 and y equals t squared minus 1. So if x equals t plus 1, then t is equal to x minus 1. So you can sub this into the y and get y equals x minus 1 all squared minus 1. Y equals x squared minus 2x plus 1 minus 1. So y equals x squared minus 2x. Part B, x equals 2t minus 3 and y equals 1 over 3t, or t does not equal 0. So if x equals 2t minus 3, then x plus 3 equals 2t, so x plus 3 over 2 is t. Sub that into the y equation, so y equals 1 over 3 lots of x plus 3 over 2, which can be rearranged to 1 over 3x plus 9 over 2, which is the same as y equals 2 over 3x plus 9. More examples. Just waiting for them to load currently. Okay, so a curve has parametric equation x equals 1 plus sine theta and y equals 1 minus cos 2 theta. Give the Cartesian equation of the curve in the form y equals f of x. So for this one, you need some of the trig equations learned earlier. In this case, cos of 2a is equal to cos squared of a minus sine squared of a, which is equal to blah blah blah. I went through all that earlier. So you can use this to get y is equal to 1 minus 2 sine squared a, theta, yeah, which can be rearranged to y equals 2 sine squared theta, if just simplify it. X equals 1 plus sine theta, so x minus 1 equals sine theta. So from there, because there's a sine theta in the y equation, you can then rearrange that to get y equals 2 lots of x minus 1 all squared. Y equals 2x squared minus 4x plus 2. Simple as that. So you'll get used to using them equations later on in the course. Modelling with parametric equations. Here's an example. A flying disc is thrown from 0, 0. After t seconds, it has travelled x meters horizontally and y meters vertically. Modelled by the parametric equations x equals t squared plus 2t and y equals 6t minus t squared, where 0 is less than or equal to t and less than or equal to 6. Find the position of the disc after 2.5 seconds. So when t equals 2.5, x equals 11.25 and y equals 8.75, just sub them in. So the answer is 11.25, 8.75. After how many seconds does the disc reach a height of 5 meters? So we're going to set y is equal to 5. So 5 equals 6t minus t squared. So rearrange that. T squared minus 6t plus 5 equals 0. Solve, and you get t equals 5, t equals 1. How far above its starting point is the disk when it reaches the point x equals 24? Well, 24 would therefore equal t squared plus 2t, so 0 equals t squared plus 2t minus 24, so t is either equal to 4 or minus 6. Minus 6 is out of range because you can't have negative time, and of this up here, so t equals 4. So, therefore, y equals 6 lots of 4 minus 4 squared, which equals 24 minus 16, which is 8. Okay, so I know I whizzed through that really quickly, mainly because a good chunk of it, well, the slide involving the trig stuff, you don't know how to do properly yet, unless you're looking back on this from later in the course. It will make a lot more sense a bit later on in the course, I think, so maybe revisit this video later. But I hope you found it useful. It's outside of the trig equation bits, it should be fairly straightforward to understand. If you have any feedback, leave it in the comments below. If you enjoyed the video or found it useful, like, share, subscribe, and I will see you in a future video. Bye bye!